Okay, we are going to have an overview right now of Chapter 7. So you should have your Chapter 7 packet. And Chapter 7 is solving systems of linear equations. Now, a system of linear equations is two or more equations involving the same variables. So here, this is a system of linear equations because both equations have an x and a y, and together they form a system. Now, I'm going to graph my first equation, 3x plus y equals 9. I'm going to do that by first changing it into slope-intercept form. And then I'm going to graph the second equation, and I'm going to also put that in slope-intercept form. So I'm going to graph y equals negative 3x plus 9. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. My y-intercept is 9. Then I'm going to go down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. Okay, now I'm going to connect my line. Didn't do a great job, but pretend I did. Okay, so that equation represents all points that make this equation true. So in other words, this point is 0, 9. If I plug 0, 9 into this equation, 0 does equal negative 3 times 3 plus 9, which is 0. Let's look at this point. This point is 1, 6. So let's plug in 1, 6. So does 6 equal negative 3 times 1 plus 9? Yes, it does. This point is 2, 3. So let's plug in 2, 3. Is negative 3 times 2 plus 9 equal to 3? Yes, it is. So every point on an equation represents a solution to that equation. So this line represents all the points that are solutions to this equation. Now let's graph the next line in our system, y equals x plus 1. So my y-intercept is 1. I go up 1 over 1, up 1 over 1, up 1 over 1. And when I graph this line, every point on that line represents a solution to this equation. So what's important here is where this system intersects. That intersection represents a point that is not only a solution to the first equation, but it's also a solution to the second equation. So let's make sure that that's true, because the solution is 2, 3. So I'm going to plug it into the first equation. Does 3 equal negative 3 times 2 plus 9? Check, it works. How about this? Does 3 equal 2 plus 1? Check, it works. So this point where the two intersect represents a solution to our system of equations because it is a solution that works for both equations. Okay, so one way to solve a system of equations or to find the solution for a system of equations is to graph our equations. So I am going to give you a preview right now of the 3 possibilities what you can get when you graph a system of equations. Okay? The first possibility is I could graph one line, let's say it looks like this, another line looks like this, and their intersection represents the solution. Now, when I'm in school, I hold 2 yardsticks and I kind of put them up in the air and say, is there any way those 2 straight, solid yardsticks could cross twice? And the answer is no, because they don't bend, and a straight line doesn't bend either. So when 2 straight lines intersect, they can only intersect at one point. Now, another possibility is that your 2 straight lines look like this, and they're parallel. Now, if they're parallel, they're never going to intersect. So if they are parallel and they never intersect, there is no solution to your system because your two equations will never share a solution. So when they intersect, there's one solution. When they don't intersect, there's no solution. And the last possibility is this is one line, and now I'm graphing my other line, and I realize, oh, look at that. They're the exact same line. We call this coinciding lines. When lines are coinciding, there's infinitely many solutions. Now, keep in mind that infinitely many solutions is different than all real numbers. All real numbers mean you can pick any two numbers and they'll work. That's not the case here. Only specific ordered pairs will work, but there's an infinite number of them. Okay? So keep in mind that infinitely many solutions is different than all real numbers. So these are all systems of equations that are graphed. Systems of equations that are graphed. Okay? Now, if you turn to page 10 in chapter 7. And if you look at the bottom of the page on page 10, you will see something that looks very similar to what I just graphed. It tells you that you will have one solution when the lines intersect. And the only way lines are going to intersect is if they have different slopes. Okay? Then you see two lines that are parallel. And if they're parallel, there is no solution because they have the same slope but different y-intercepts. Okay? And then finally, for the last one, you have infinitely many solutions because the lines coincide. That means one right on top of the other. And they have same slope, but also same y-intercept. Okay? So this is on page 10. You need to know this. There will be vocabulary on the quiz. So when you have different slopes, you have one solution because the lines will intersect. When you have same slope but different y-intercepts, you will have no solution because they'll be parallel lines. If you have same slope and same y-intercept, they're coinciding lines and you'll have infinitely many solutions. Now, in addition to knowing the vocabulary on how to describe the lines, and when we describe lines, we use words like slope and y-intercept. We're also going to describe the system. Now, the system has different vocabulary, okay? When you have any solution, we call that a consistent, and you should add this to the notes on page 10, a consistent system. Okay, this has no solution, so it's an inconsistent system. And this has infinitely many, so we call it a consistent system. So if you have at least one solution, it's called consistent. If it's inconsistent, end of story, no other vocabulary. But when you have a consistent system, it can either be consistent and independent or consistent and dependent. Okay, so this is a consistent, independent system. This is independent because the lines are going in their own direction. This is consistent and dependent. It's dependent because one is right on top of the other. It's a dependent system. So you should copy consistent, independent system, inconsistent system, and consistent dependent system in your notes on page 10. Okay, and this is the end of this video. We'll start another one on page 2.